Alright, let's get some practice working with vectors now that we've talked about how to add them when they're parallel or perpendicular. Here's a typical problem. A dog runs 3 miles south, then 6 miles west. The owner of the dog would like to get his dog without having to travel the same path as the dog. Find the shortest displacement to the dog with direction. We'll talk about this word displacement in more depth later. It basically just wants to know how far is it to get to the dog and what direction does the owner have to walk in. Alright, let's go ahead and put in our coordinate system on this graph. We're going to say that this is north, east, south, and west. Alright, and that the units here are all going to be in miles. That's just going to be kind of an understood thing for us. Alright, the dog runs 3 miles south, so let's go ahead and put him at the origin first, and we'll run him 3 miles south, which puts us right here. Then he runs 6 miles to the west, so we'll move him over 6 miles to the west, and this is your location of your dog here. Alright, I'm just putting these arrows in to show that they're vectors. Okay, now, you, the dog owner, need to go track down your dog, but you don't want to have to walk all that distance. You want the shortest distance between 2 points, and we all should know that that is a straight line. Alright? So you want to move in that direction, and you need to know how far that is. Alright, so this is a right triangle, just like we've been working with. Okay? So this should be easy for us to figure out. This is 3 miles, and this one is 6 miles, and we need to figure out what the hypotenuse is, or our resultant vector. Alright, so what can we do to figure out the magnitude of that distance there? We need to use Pythagorean theorem. Good. So we can say that 6 miles squared plus 3 miles squared, and actually these are negatives. It doesn't matter since we're squaring them and they're going to get taken care of, but we should put them in there, is going to be equal to the hypotenuse squared. Alright, so 6 times 6 is 36, and that gives us miles squared, plus 9 miles squared equals the hypotenuse squared. So we get 45 miles squared equals the hypotenuse squared. We want just the hypotenuse, so we will take the square root of everything. And we get that the hypotenuse is, and let's put the correct significant digits. Notice up here in the problem they just give us a single number, so one significant digit. That puts us at 7 miles. Alright, so our hypotenuse vector here is 7 miles long that you'll have to travel to get to your dog. Alright, now we need to know in what direction do you need to travel. Okay, you can either figure that out based on 0. Remember, 0 degrees is over here. So you can figure out what direction in reference to 0 you need to travel. Or we could figure out, let's say if we figured out this angle here, it would be in reference to west and south. Alright, and I think that that makes more sense for us to use that angle. So that's the angle that we're going to go ahead and find, is this one right here. Alright. So we're finding this angle theta here, and that means we have to use Sohcahtoa. Now, since we're finding an angle, we're going to use the inverse of these functions. We already know what the sides are. So let's name our triangle based off of our angle theta. That means that this is going to be the opposite side, this one is going to be the adjacent side, and we already know this is our hypotenuse. So we need to figure out something that has to do with any of these sides. Really, we could use any of those if we want. Let's go ahead and use tangent, since that involves things that the problem gave us and not something that we calculated on our own. So we'll write that out. The tangent of theta is equal to the opposite over the adjacent. We want theta by itself, so theta is equal to the inverse tangent of opposite over adjacent. So we get the inverse tangent of 6 miles divided by 3 miles. And those do have their negative signs, which again are going to cancel out. So theta is equal to the inverse tangent of 2, which is 63.4349, so on and so forth degrees. We are going to go ahead and just cut that off, let's say in the 10th place, I think is a good spot to round that off at. So theta will be equal to 63.4 degrees on that one. So let's write our entire resultant vector. The resultant vector magnitude and direction would be equal to 7 miles at 63.4 degrees, and now we have to say which way that 63.4 degrees is moving. And down here in our angle, it is moving towards the west, away from the south. So we would say west of south. If you wanted to go from 0, then you'd have to come around this direction. But I think for us, if you were using like a compass or something, then figuring out what this angle in relation to west and south makes more sense. Alright, so that is that problem. Alright, here's another typical problem. A boat travels 7 miles east, then 2 miles south, then 5 miles west, then 6 miles north, then 3 miles east before it runs out of gas. The captain radios into the Coast Guard for help. What magnitude and direction should the captain tell the Coast Guard to give them the most direct path to his boat? Alright, so obviously the Coast Guard doesn't want to follow all of those different routes to get to the person. They may run out of gas also. So the captain needs to be able to tell him where he is in the ocean. So the first thing that we're going to do is go back up here in the problem, and we're going to break all of these different directions into north, south, and east, west. Alright, so we've got north, south, and we've got east, west. The reason for that is we want to get an overall picture of what happened. Alright, so let's see, they went 2 miles to the south, and I'm putting negative because south is going to be downward. Let's go ahead and actually put the directions on the graph. North, east, south, west. Alright, so he went down 2 miles, then he went 6 miles to the north, so that's going to be positive 6. That's all of the north-south stuff. Now let's do our east-west directions. We've got 7 miles to the east, which is going to be in a positive direction. So we've got 7 miles here. Then we've got 5 miles to the west, so I'm putting negative because in the westerly direction is negative. Then 3 miles east, and that's the end of that one. So now we'll add up both sides here. So 6 plus a negative 2 is a positive 4. 7 minus 5 is 2, plus 3 is 5. Alright, so we've got, since this is a positive number, that means that it is to the north. And since this is a positive number, then that means that it is to the east. Alright, so the boat moves 4 miles to the north and then 5 miles to the east. Alright, so now we need to get the shortest point between the origin and the ending point. Alright, so that would be, here's the origin, here's the final point, and we need that distance between them. Notice that that's a right triangle, and so we can use the Pythagorean theorem to figure out how far our little Coast Guard ship needs to travel. So let's go ahead and do that. We have, in the northern direction, we have 4 for that side of the triangle, and in the easterly direction we had 5 for our triangle. So we've got the resultant vector is going to be equal to the square root of 4 squared plus 5 squared. So the resultant vector is equal to 6.403124237 miles. Alright, and we need to have just one significant digit because all the ones in our problem have just one. So that leaves us with a resultant vector magnitude of 6 miles. Now we need to get an angle for the ship to travel in. And the angle that we're going to get needs to be this angle down here. You kind of can't see it because this ship is covering it, so let's go ahead and have our ship go out to meet the boat. And so we are talking about the angle down here, and that's going to be facing in that direction, so we're going to be moving in a northerly direction away from east. Okay, but we are not traveling from 0. If we were traveling from 0, we would be finding this angle. We're finding this one. We're still traveling away from the eastern direction towards the northern direction, but we're not going from 0. So just make sure that you're aware of that if you're going to put it in reference to 0. Alright, as we do every single time, if we're going to be finding a angle, we're going to have to use Sohcahtoa, so let's write that down. And since it's an angle that we're after, we're going to do the inverse. Now, let's see here. We know, or we need to name our triangle. We've got this as the opposite side, so we can write that up here. And we have this as our adjacent side, so we can put that in there. And we're trying to find the hypotenuse. No, we're not. We've already found the hypotenuse. Alright, so let's see here. If I want this angle, I need something that has opposite and adjacent, because those were things that were given to me in the problem. That gives me tangent. So, theta is equal to the inverse tangent of the opposite side over the adjacent side, which means we need to take the inverse tangent of 5 over 4, and theta equals 51.34019175 degrees. Alright, again, we're going to go ahead and just cut that off here at the tenths place. So theta is going to be 51.3 degrees. And now we need to say where that degree measurement is. Again, we are moving towards the north from the east, so that is going to be north of east. So in order to write our complete vector statement up here, we're going to say that that is 6 miles at 51.3 degrees north of east. Okay? If you had wanted to put that in terms of 0, notice that this whole angle from north all the way down to 0 is 90. You've got 51.3 degrees of that 90, so you just need to find this missing piece here, and you could say that it's that angle from 0. So anyways, I think that is enough for today. Thank you for learning with me, and I will see you next time.